Hello, my name is Levi Watson, and welcome to my habitable planet. So what makes a planet habitable? Well, according to NASA, this involves extended regions of liquid water, conditions that are favorable for assembling complex organic molecules, and energy sources that can sustain metabolism. So a key aspect in determining whether a planet is habitable is observing it within its habitable zone. This is defined as the orbital region of a solar system, where a planet is such a distance away from its star that liquid water can be sustained and a planet can therefore support life. In stars similar to that of our solar system, the Sun, the habitable zone is approximately 1 astronomical unit away from it. The smaller a star, the shorter the distance is, and the opposite occurs for large stars. As stars use up their hydrogen and helium fuel, they expand, and this pushes out habitable zones further and further throughout their solar system. During this process, these stars also consume, in a sense, the planets that surround them. This vaporizes anything on the planet and the planet itself, making it essentially non-existent and therefore unseeable. So some other factors that determine a planet's habitability is atmospheric pressure, atmospheric composition, and greenhouse gases. So looking at greenhouse gases, such as carbon dioxide and methane, these build up in a planetary body's atmosphere and involve the trapping of heat that maintains the temperature on the planet, keeping it warm enough to maintain liquid water. Atmospheric pressure itself is the interaction between temperature and gravity, keeping an atmosphere stable. So gravity needs to be high, whilst the temperature needs to be low. This is what occurs on Earth. Atmospheric composition, meanwhile, is what is involved in the atmosphere. So on Earth, our atmosphere is comprised of 71% nitrogen, 21% oxygen, about 1% argon, and about half percentage of carbon dioxide. There are also trace amounts of other gases, but these are too many to name and have a bit of a smaller impact than the others. All these features are incredibly important to the habitability of a planet. So now let's turn to my planet and its composition. This planet is twice the size of Earth, making it a super-Earth. It orbits 1 astronomical unit from its parent Sun-like star. It contains 1 moon that is in synchronous orbit with, allowing it to produce tides on its liquid ocean. Its atmosphere is comprised of nitrogen, oxygen, carbon dioxide, and argon, with trace amounts of other gases, similar to Earth, so that we know that it can support life. Water itself was brought to the planet from external sources, such as comets, meteorites, or asteroids, which is similarly believed to have occurred on Earth and brought about a massive ocean. In regards to the planet's topography, it'll have plate tectonics, not because it's necessary, but because it leads to greater volcanic activity, greater geological changes, and assists in supporting the greenhouse effect, which stabilizes the ocean. The ocean itself is vast and covers around 70% of the planet's surface. This is important as it can support marine life and terrestrial life. Upon each continent, there will be their own inland water reserves in the form of lakes and rivers, supporting inland marine life, as well as giving any intelligent life or animal life a source of other foods and liquid close by, no matter where they are. Mountainous regions will also occur, which have formed from impact craters from external sources, as well as the movement of plate tectonics. Now turning to the life present on the planet, this will initiate with microbes, starting with singular-celled organisms that eventually evolve into eukaryotes and splitting off into plants and animals. Microbes are integral to every aspect of supporting life. Plants, meanwhile, play an important part in minimizing the greenhouse gas effect so it doesn't go into a runoff, making the planet inhabitable by taking in through photosynthesis and letting out oxygen that supports microbes and other animals. Returning to microbes, they actually can play a role similar to plants, but not to the same extent. Animals themselves will evolve at a later time and could take a similar appearance to smaller mammals and reptiles, fish, eventually someday forming into what's considered intelligent life, such as humans. Thank you for listening to my presentation, and I hope you enjoyed learning about habitability and my habitable planet.